I was inspired earlier this year when my teammate Ian taught a class on building custom keyboards and macropads, and check out what I built. And this got me really excited because building a custom keyboard has been on my project bucket list for years. Now I know that I can just go out and buy a kit. In fact, DigiKey sells Macropad kits. But you know me, I don't buy kits. Ordering parts and designing a custom PCB is way more fun. My name is Zach and I'm the Byte Size Engineer. This is my latest DigiKey order and it contains all the parts I need to build a custom Macropad. If you're not familiar with Macropads, they work the same way as the keyboard plugged into your computer, except that you can customize the layout. So if you want something very specific or ergonomic, you can do that. The reason Macropads are useful is that you can assign custom keyboard shortcuts to each button. I asked my Discord community for ideas on what they might use a Macropad for, and I got all sorts of great answers. For creatives, with a quick push of a button, they can access different paintbrush sizes and apply filters to photographs. And engineers like Macropads because we use all sorts of different CAD software that has so many menus, so many buttons, and so many tools. And that's exactly what I'm going to use it for. I use Fusion 360 to do all of my 3D modeling, and I use KiCad for all of my PCB design. And I want to be able to quickly access those tools with a push of a button on my desk. So let's walk through the schematic that Ian and I came up with. The first thing we wanted to decide was the microcontroller. Ian and I talked through several different options, and we decided on the RP2040 module because it has a lot of flash and lots of GPIO pins. In fact, we ended up going with the Seeed Studio Xiao module, which is a module that you can solder directly to the PCB, and it already has the USB-C connector, which is a great bonus. The RP2040 microcontroller has lots of GPIO pins, and it would allow us to put a lot of key switches on there, but we didn't want to be running into the limit of GPIO pins, so we thought it would be a good idea to use an I/O expander so that we wouldn't be running into that limitation. Speaking of key switches, that was the next thing we added to the schematic. We ended up going with a 4x5 matrix, which gives us 20 buttons that we can customize. We put 2 rotary encoders on this design because it's always fun to spin knobs on macropads. And of course, no macropad is complete without a grid of RGB LEDs. We ended up getting the SK6812 kind because it's an addressable LED that you can reverse mount on the backside of the PCB, and then you cut out a hole in the PCB and it shines through. It's really cool. And finally, we wanted to put a linear potentiometer on there because it would be kind of cool to be able to change settings up and down using a linear potentiometer. After a little bit of cleanup, this is what the schematic ended up looking like. Now that the schematic was done, it was time to do the board layout, and Ian did a fantastic job with this. Here's what it looks like, and I'll even give you a 3-dimensional view of what the board should look like once we get it manufactured. That looks great. Oh yeah, I forgot to mention that we wanted the ability to add an OLED display on here, so we used an I2C quick connector to be able to add on a display at the end, which is going to be really cool to have on this Macropad. This board is looking great, it's ready to be manufactured, and to do that I can send it off to DigiKey using their DK-Red service. While I wait for the PCBs to arrive, let me show you how a microcontroller can read a key press and send it to the computer. I'm using the Seeed Studio Xiao RP2040 microcontroller for this example. If I go into the Arduino IDE and I install the Adafruit Tiny USB library, then I can go into the examples for that library and I find the HID keyboard example. HID stands for Human Interface Device, and it's a protocol that your mouse or your keyboard uses to communicate with your computer. This is a really great example to get up and running quickly. If I look here in the code, I can see that it's using pins D0 through D3 to read as button presses. Now, if I go down a little bit further, these 4 input pins will map to the numbers 0 through 3 respectively. I'm going to go ahead and upload this example to my Xiao module. Before I can upload this, I need to make sure that I have the USB stack set to Tiny USB, and then I'll go ahead and upload this to the microcontroller. While that's compiling, I'm going to connect this little mechanical key switch between ground and digital pin 2. Cool, now that that's done, I'm going to open up Notepad and see if this worked. Okay, let's see, when I press the key switch, I should see the number 2 appear in the text editor. And it works. I can type the number 2, and if I move that key switch over to digital pin 3, I should see a 3 on the screen. Isn't that cool? So you can create an entire keyboard just by reading these button presses with the GPIO pins. Here are the PCBs that I ordered for this project, and they turned out awesome. I'm getting really excited about assembling this custom Macropad. In this box, I have all of the components that I need to assemble the board, but before I can put those on, I need to put on solder paste. And to do that, I ordered a solder stencil. So I'll use the extra boards here to create a little jig around my PCB so that I can use the solder stencil to apply the solder paste. Now I can align the solder stencil with all of the different pads on the board. I really want to take my time and carefully do this step so that I get all of the solder paste in the right spot. So now I'm ready to apply the solder paste, and I'm going to use a plastic credit card as a squeegee to apply the paste. We used KiCad to design this board, and within KiCad there's a plugin called the Interactive Bill of Materials, and that's going to make assembling these boards so much easier. So first up, I've got the 0.1 microfarad capacitors that accompany each of the RGB LEDs. Okay, next we've got the diodes. We've got a diode for every single switch on here so that it prevents current from flowing in the wrong direction. While I'm here, I'm also going to install the RGB LEDs as well as the I/O expander, because I need to be able to see the markings on the packages to figure out which way they're oriented on the board. All right, I am back over here because I'm almost done placing all of the surface mount components. There are still several through-hole components, including all of the key switches, but right now I'm focusing on finishing all of the SMD components. We decided to put on this I2C expansion connector because there are a lot of peripherals you might want to plug into this. I'm going to be connecting an I2C OLED display, but you could connect other peripherals to this board as well. Now that all of the surface mount components are placed, I can throw it into my solder reflow oven that I built in a previous video. I programmed the solder reflow profile into the controller, and I'm ready to start. The current temperature is 75 degrees C, and it's climbing up. If you're interested in learning more about the solder reflow controller, I made a whole video about it going into the details of the PID feedback loop. Okay, so we're at 150 degrees. We'll let it soak there for a bit before it ramps up to the reflow temperature, which is 235 degrees C. All right, here's where things are gonna get interesting. I can see some of the smaller components starting to reflow, and then eventually bigger parts will start to reflow, like that microcontroller will probably be the last thing to go. There it is. All right, we hit our maximum temperature of 235, and now it's starting to cool down. I'm pretty sure this worked, but we won't know until everything cools down and I can take them out and give them a visual inspection just to make sure that everything reflowed properly. Sometimes what happens when those tiny parts heat up is that they kind of pucker and then they fling off the board into oblivion and you can't find them. So I'm hoping that didn't happen, but that's not a big deal because I have replacement parts, and if I need to, I'll just replace those by hand. All right, the boards have cooled down enough for me to open the door and pull them out. And I'll get my first look at it here. Doesn't look too bad. I might have to do a little cleanup on the I/O expander, but overall this is looking pretty good. How did the other one turn out? Yeah, that one actually looks even better. I think I had a little bit too much solder paste on the I/O expander on this board, so it kind of squished out and made a little bit of a mess, but that's not too hard to clean up. This one looks a lot better. Before I populate all of the through-hole components on these two boards, I can actually test to see if they work. So let's head over to the computer and load up some firmware to see if these boards work. There's an open source firmware called QMK that most people use when they're building their own custom keyboards and macropads. So I'm going to show you an example of what a QMK firmware might look like. I've got the file open here, and this keymap.c file is where you would input all of the information of what keys you want to assign to each key on your macropad. Then you can open up the keyboard.json file. This JSON file tells the compiler how your keyboard or macropad is set up. If you're gonna mass produce something like this and you're never gonna change the firmware, this is probably the route you wanna go. But for my macropad, I want to be able to edit the keys and adjust the settings on the fly. So I had my team member Ian compile a QMK firmware that is compatible with Vial. Vial is an open source software that lets you configure your QMK firmware on the fly. I can open up Vial and change all the different functions for each key, and I can set up macros and all those things without having to recompile the firmware and load it onto the board. So the first thing I need to do is plug in this board, and I'm gonna hold down the boot button, and I'm gonna reset it, and this is gonna put it into the bootloader mode. When I do this, it comes up like an external storage device, and I can drag and drop files on there. I'm gonna open up the UF2 firmware that my team member Ian configured, and I'm gonna drag and drop that onto this board. Once it's finished copying, it reboots itself, and now it's ready to go. So I'm gonna go back to Vial, and I'm gonna start Vial Web. You could download the program and run it directly on your computer, but I'm just gonna run it in the web browser. So I'm gonna start Vial, and I'm gonna select the board, hit connect, and it's starting up. So here's my Macropad. And now you can see all of these LEDs are pulsing through the different colors, and it's doing different animations. I need to test all of these key switches and my rotary encoders to see if they work. And to do that, I'm gonna use the matrix tester in Vial. Since I don't have key switches installed yet, I'm just gonna use a set of tweezers, and I'm gonna make contact between these two pads to see if this key switch actually works. So that top left key switch is now lighting up on the screen. That one works. I'll move over, test that one works. And I'll go through and systematically check every single one of these to make sure they work. Okay, I came across one that doesn't work. So I'll make note of that, and I'll keep going. Oh, interesting. It doesn't look like any of the 4 key switches on this entire row work. How about this last row? Nope. Okay, so those bottom 2 rows don't work. Let's check the rotary encoders. Okay, those don't work either. I'm just gonna go through again and check some of these solder joints just to make sure everything is making good contact. So I came back to the microscope and I noticed something on R15, R16, and R17. Those are the pull down resistors on row 4, row 5, and row 6 of my matrix, and those weren't soldered properly. So I'm gonna reflow those and fix those solder joints real quick, and hopefully that fixes the problem. Okay, so let's plug this in and see if that fixed the issue. I'm gonna test the top row, row 2, row 3, row 4, here's a moment of truth. That fixed it. Okay, that's great. So that was all it was. It was just those pull down resistors. And here's row 5. That works, awesome. Oh, I'm so relieved that it wasn't something more complicated. All right, let's try the push buttons on each of the rotary encoders. Cool. So that works. I'm really thrilled. So now I can move forward and I can start populating all of the through-hole components. But before I do that, I think I might run this through the ultrasonic cleaner and give this board a little bit of a cleanup because I added a lot of flux and I don't like all that extra residue on there. I want these boards to be clean and look really nice. The main component that I need to solder onto these macro pads are these key switches. This is one of the parts of custom macro pads and keyboards that I'm not as familiar with, but there are literally dozens and maybe even hundreds of types of key switches that have different qualities and different configurations that you can choose from. For this project, I just chose a general purpose key switch, but just know that if you get into this hobby, there are so many options to choose from. Now I'm ready to solder all of these key switches to the PCB, but there are a couple of things I need to consider. When I solder these key switches to the PCB, I want to make sure that they're all lined up in a nice, neat grid. There's a little bit of play in the through-hole pad. If I'm not careful, each switch might be off by a little bit, and when I get them all on there, it'll be really obvious that they're not lined up perfectly. The second thing I need to consider is that these switches are really designed to be panel mount. They have some snap-in-place fingers that grab onto the panel that you push them through, and if I try to solder these onto the board and then put my case around it, it's not gonna work. So the takeaway is that I really need to design and 3D print the case for this first. The case will help me align everything so that none of the switches are wonky. So I've gone ahead and I've designed a 3D printed case in Fusion 360. The first thing I needed to do was create a rectangle in a sketch. This is going to be the outer dimensions of my case. Then I can extrude that rectangle. Eventually, I know that my design is going to be split into two halves, and I'm going to hold the two clamshell halves together using screws. So I've got some mounting holes for that. Then I can round over the corners, and I'm going to split that body into two. So I've got a top half and a bottom half. Once that's split, I'm going to use the shell command, and that's going to hollow out the inside so I have room for the PCB. Remember, my PCB has the USB-C port on the side, and so I need to have a hole in the side of my case so that I can access that port. The next thing I need to do is give myself a cutout for this linear potentiometer. So I've created another sketch for the linear potentiometer as well as the dimensions for each key switch. So the first feature I want to cut out is the hole for the linear potentiometer, and then I'm going to cut out one hole for the key switch. Then I used the rectangular pattern feature to create all of the holes for the key switches. This is looking pretty good so far, but there is one more thing I want to consider for this design, and it was sort of an afterthought. I wanted to have an OLED display for this Macropad, so I found this one from SparkFun, but unfortunately it is like just a little bit too big to fit between the two rotary encoders. That was a little bit of an oversight on my part. I wanted these rotary encoders to line up with the columns on the left and right, and by doing that, it didn't give me enough space to fit the PCB in here. So unfortunately, I'm probably gonna have to put this OLED display on the outside as an attachment. I may decide that I don't even want it, so I kind of have the option to attach it on the outside or remove it altogether. So there is some flexibility here in this design. So to accommodate this OLED display, I've got this external component here that screws on. You can see there's a cutout for the display, and that's just gonna screw on to the outside like that. I'm feeling pretty confident with this design, so I'm gonna go ahead and 3D print the case, and we'll start assembling this Macropad. There's one final thing to do before we program this Macropad, and that's keycaps. I went ahead and I printed some solid red keycaps. These just snap right onto the top of the key switch. These are a little bit tight, but I'd rather have them too tight than too loose. All right, the buttons are done. They look and they feel great. There's just one final step, and that's to program it. I've got the Macropad plugged in, and I'm ready to program it with some keyboard shortcuts. The software that I use most often in my day-to-day workflow is Fusion 360. It's a 3D modeling software. So I'm gonna program this Macropad to use some of the keyboard shortcuts in Fusion 360. I'm not gonna go through and program every single keyboard shortcut. I just wanna give you a quick little sample of what is possible with the Macropad like this. When I open up Fusion 360, the very first thing I do is to create a sketch. So let's assign that function to this upper left-hand key. So I'm gonna open up Vial, which I showed you a little bit earlier when I was testing the keys. Now I'm gonna use it to program the keys. So I can select the upper left-hand button, and I'm gonna go into the quantum menu, and I'm gonna select left shift, and then I'm gonna select inside there, K. So Shift K is the keyboard shortcut for creating a new sketch. Let's open Fusion 360 to see if this works. I've got a blank project here, and I'm gonna select my sketch plane, and it works. All right, let's go and program the next button over, which is gonna be draw a rectangle. So I go back to Vial, and I select that second button, and this one's much simpler. It's just the letter R to create a rectangle. That's all there is to it. I literally just click the letter R, and I can go back to Fusion and test it out to see if it works. Okay, and there's the starting point for my rectangle. You see where I'm going with this. I could open up a sketch, create a rectangle, add dimensions, and it would speed up my workflow tremendously. That's the whole point of this project. That's the whole point of this custom Macropad. It is to be custom to my workflow. These examples are really just scratching the surface of what's possible with this customization. Really, the possibilities are limitless. You can go into Vial and create macros that have multiple lines of instructions. Really, you can get crazy with the customization. But for me, it's all about speeding up my Fusion 360 workflow. So I've gone ahead and I've programmed all the rest of these buttons to be my most frequently used keyboard shortcuts. But as I look down at this custom Macropad, all I see is a giant grid of blank red buttons. How am I going to remember what I programmed on each one? I'm not smart enough to remember all these. Thankfully, I have a solution. Custom keycaps. As I was printing these out, it occurred to me that I have a multicolor 3D printer, and I could use the multicolor 3D printer to print the icons of each keyboard shortcut. This took a lot more time than it might seem, but I think it's going to be worth it to have these icons sitting right here on my Macropad, and there will be no confusion as to which key does what. Now, you may have noticed that I left one of these keycaps red. Do you remember earlier when I talked about customization? I might have gone a little bit overboard here. I told myself that if I finished this project, that I would be allowed to press this button, and since it's the end of the video, now is the time. Are you ready for this? Bet you didn't know I had these moves. In case you haven't seen it, I just uploaded a video called 8 Things That I Wish I Had Known Sooner. You can watch that right here on the DigiKey YouTube channel. Now, if you don't mind me, I'm gonna keep dancing.